Tetris game now. So I'm gonna run the game. So as you can see, this is a basic implementation of the Tetris game. So you can see there's randomized Tetrises. It also shows the score as well as the next Tetramino that's going to show. See, this one's the freeze up power mode. So once it locks in, it's gonna go back to the color it was originally in. We can rotate it, you can move it left and right. This is a bomb, so once it interacts with it, it's gonna clear the path. So let me see if I can get a full row. So once it detects a full row, it's gonna clear the row. It's a bomb. It's gonna explode the surrounding grid. It's gonna clear the surrounding grid. This one's a slow freeze mode, so it's gonna go a little bit slower than the regular Tetraminos. I'm gonna let it run. It's a bomb. Okay. And once it gets to the top, it's gonna display game over. So to look at the code, how we implemented the abstract factory design pattern is through creating a first in abstract factory class power up Tetramino factory that defines the method create for different power up Tetraminos. Then we created specific factories, freeze Tetramino and the bomb Tetramino factory, which create instances of the power up where you can specify either the freeze duration or the explosion range. This is also called by the game class by the spawn method. So as you can see at the beginning, we've initialized the factories, and the spawn method gets called in the run loop, which creates different Tetraminos. So in here, to randomize everything, I had a range where it's 1 to 6, and whatever number it lands on, for example 6 or 3, it's going to use the factories to create the corresponding Tetraminos. So this one creates freeze and this one creates the bomb, else it's just going to be the standard Tetraminos. Alright, and then for the freeze power up, where it is inherited from the Tetramino class, there's attributes like the freeze duration, and it overrides the lock Tetramino class, which then applies a freeze effect with the freeze duration. So this is defined in the game class. For the apply method, it sets the current speed to the frozen speed and sets the flag is frozen to true, which can be used to implement the draw method in the Tetramino class to check if it is in freeze mode, which then sets it to display in light blue. The speed then gets reset from the method after the run loop. So this is going to be reset where the current speed is going to be normal speed and the flag is reversed in the run loop. The bomb power up is created in the Tetramino class. It is also inherited from the Tetramino class. The color of the bomb is going to be darkened to indicate it's a bomb, and we also define the explosion pattern, which is copied from the Tetramino shape, and the explosion range. So it also overrides the lock Tetramino class. This is the key functionality for the explode. It then calls the explode, which is the key functionality of the bomb power up. So basically, it iterates through the grid cells within the specified range of the Tetramino's position and setting those cells to be empty, clearing that portion of the grid. Upon locking of Tetramino into the grid, the game immediately checks for any lines that have been completely cleared through this method, which is called in the game. It's defined in the game for checking for any full lines to clear. This is designed to remove full lines from the grid and adjust the score accordingly. All right, that sums up my presentation. Thank you for listening.